Hello everyone, welcome back to the channel. Now in this video we are going to implement the height method because without implementing the height we cannot calculate balance factor and we will not know what are the rotations that we need to perform. Okay, so in last video, as you know, we have already implemented the insert method. Now in this video let's calculate the height of each of the node. Now how are we going to do that? Again, recursion is our best friend here. So what we are going to do, when you actually have to calculate the height, after you're done finding the correct location and inserting your particular element, right there itself, for that particular node which is root at that particular moment, you're supposed to find the height there itself. Now how do you do that? For that you're supposed to do root dot height calculation. Okay, now currently you don't have a variable of height, so now let's create that variable. Okay, private int height. Okay, so now let's set the height. Now for height, how we are going to set the height? Now logically we are already calculated height in binary search tree as well. How we were able to do that? Last node we are considering the height as 0, and recursively, how whenever we are going up we were adding 1 to calculate the height, and we were checking who has the maximum height in the left side, left subtree or right subtree. Whichever has more height, we were considering that only, right? That same logic we have to use here. Okay, that is math dot max of your height of root dot left child comma height of root dot right child, and then you have to do that plus 1. As you can see right now, we don't have the height method, right? So let's create that method. Okay, that will be private int height. It is going to take the AVL node as an input. Okay, now let's write the logic. If node is equal to null, it is supposed to return -1. If it is not equal to null, return whatever the height of that particular node, so that we can add +1 there. So if the node value is null, then it is going to return -1, or it is going to return the node height. So that's all the logic to calculate the height of that particular node. Okay, now let me debug again, show you if we are able to get the height of each of those nodes or not. Okay, so our tree is visible, which is this AVL tree. Now let's look into the height value. Yeah, so as you can see, 10, which is our root node, has the height of 2, and then 20 has the height of 1, and then 30, which has the height of 0. So that's how you calculate the height of the tree. Now what is the next thing? Now you can actually go ahead and calculate the balance factor so that you can perform the rotations. Okay, so in next video we'll be calculating the balance factor. That's all as part of this video. See you in the next one. May the source be with you.